Assalamu alaikum everyone, this is me, Mr. Asam Zidane, and today we are going to explain together the collisions and take some examples about the collisions and the conservation of momentum. And today exactly we are going to discuss some problems and take how to solve these problems together. So let's start within the first part. Okay, so now we are going to explain the first part of this, or the first question. As we can see here in this example, a clay ball with mass of 0.35 kilogram. So we have the first ball. Okay, so this first ball has a mass of 0.35 5 kilogram. Okay, and another one within the same mass برضو. Okay, so it's 0.35 kilogram. So the two balls at rest. So the second one is at rest, which means its velocity equal 0. And the two balls stick together. So after collision, the two balls stick together. So now the two balls stick together by this way. Okay, and the final velocity of the balls is, and the final them is 2.1 meter per second. So this is the final velocity. What was the first ball initial velocity? So this is the question. He asked about the initial velocity for V1. So this is the question. Now as you can see here, we have M1, this is the first mass, M2, which is the second mass. Okay, and and now here we have the combination of M1 plus M2 when both are stick together. So how can we solve a problem like this? As you can see here in this problem, the question just asks about the initial momentum. From the problem, we can just understand this a kind of collision between two balls, and the two poles now have a perfect inelastic collision. So this type of collision is called perfect inelastic collision. Okay, so this is perfect inelastic collision. So how can we answer this? So we use together the law of conservation of momentum, which is the first mass states that, okay, so M1 V1 plus M2 V2, this is equal, open a bracket, M1 plus M2, because the two masses stick together. So we use this formula when the two masses stick together. So now we have to substitute the numbers, as you can see here. So just put the numbers. So the first mass is 0.35 times the unknown velocity. So this is the unknown velocity. It's V times V, and plus M2, which is 0.35 times its velocity, which was 0. He told me its velocity was 0. Then add the two masses together, because this combination now between the two masses, now the two masses act as one mass. So this is 0.35 plus 0.35, okay, times the final velocity, which was this velocity. It's 2.1. Okay, so now we need this. So at the end, this is equal 0, this part equal 0, and this part equal 0.35 V, and this is equal 0.7 here. Okay, so this is 0.7 times 2.1. So using calculator to figure it out. So at the end, the velocity equal, okay, 0.7 times 2.1 divided by 0.35. So at the end, you will find the initial velocity. Okay, so the initial velocity in this situation, its unit will be mass meter per second. Just use the calculator to figure it out. So I take this side. Okay, guys. So I just take this side. Okay, as you can see here. Okay, divided by that side here. Okay, to figure out what is the final velocity. Okay, so this is about the first problem. About the second problem, okay, guys, as you can see in this problem, a bowling ball with a mass of 0.7 kilograms strikes a pin that has a mass of 2 kilograms. So now this is interaction also between two objects. So the point here is, this is the ball, and the ball is 7 kilograms, and this ball strikes, okay, the pin. We can just draw the pin by this way. Okay, this is the pin. Okay, and the pin is 2 kilograms, so this is the mass. Then the pin flies forward within a velocity of 6 meters per second. So after collision, this pin just move forward by 6 meters per second. So this is 6 meters per second. And the ball continue forward at 3. And the ball, okay, so this is the ball, continue forward as 3. So this is 3. As 4 meters per second. So 4 meters per second. What was the original velocity of the ball? So actually the question here is about what is the velocity of the ball. And the pin, of course, the pin was at rest. Okay, from the problem, understand this. A bowling ball with a mass of 7 kilograms strikes a pin that has a mass of 2 kilograms. The pin flies forward within the velocity. So in bowling ball or in bowling game, just the pin is at rest. So the pin here, okay, its velocity is 0. So how can we answer a problem like this? Actually, let me tell you something. Okay, it's exactly like the first problem, but the point here is the two balls after the collision, as you can see here. So the two balls after the collision. Okay, so these two balls, each one takes its own direction. So actually both move in the same direction forward. Okay, so the right equation, or the equation you have to use in this situation, we use this formula, which is m1 v1 plus m2 v2 equal, this is the momentum, or the total momentum before the collision, equal the total momentum after the collision, which is the momentum for the first one, m1 v1, dashed to just differentiate between initial and final, plus m2 v2 dash. So now we are going to just answer this. Okay, so the first mass, just substitute the numbers here. The first mass, which is 7 kilogram times v1, this is what we need. Okay, plus, okay, the other side here, this is m2, which is 2 times v2, which is 0. This is equal, okay, m1, which is 6, m1, which is m1, this one, it depends, m1, which is 2 kilogram. So this is 2 kilogram times its velocity, which 6, plus, okay, the mass for the ball, which is 7, times this mass times its velocity after the collision, which is 4. So at the end, guys, this is equal 0, and this is equal 7 v1 as it is, no change, and this is equal 6 times 2, this is 12, plus 4 times 7, which is 28. Okay, so at the end, actually, so here, okay, so this is v1 equal, okay, 12 plus 28, okay, this is 40. So this side here, okay, this is equal 40. Okay, so this will be 40 divided by 7 to figure this out. So the final velocity actually equal 40 divided by 7 meter per second. Okay, so this is the right answer, and you can use just the calculator to figure it out. Okay, if we just come back to this problem, okay, as you can see here, okay, maybe I can just add another question. I can just add find the change in kinetic energy. So here I can just write this. Here I can just write, okay, in this problem, find the change in kinetic energy. Find the change in the kinetic energy. So if you have a question like this, what you should actually do, okay, let me tell you how can we answer this exactly. Okay, so if I have a problem like this, you have to figure out, okay, pick up the given. So let's just make this line here. So m1, we know it, this is 7 kilogram. Okay, so this is 7. m2, which the bin, which is 2, and the velocity before the collision and the velocity after the collision. The velocity before the collision here, before collision, let's write this before collision. So the v1 before collision equal, we figure it out, which was 40 divided by 7. So this one here, this is 40 divided by 7, which is 5.7 meter per second. So v1 is, now I figured it out, 5.7 meter per second. Okay, v2 equals 0. This is before the collision. Okay, then after the collision, so v1 dash, which that for the ball, which is 4 meter per second, and v2 dash, this is the velocity after the collision, which is actually it's 6, okay, meter per second. Now the question is, I need to figure out what is the kinetic energy before and the kinetic energy after. So this is the question. So to figure out what is the kinetic energy, okay guys, before, this is equal half mv1 squared plus half mv2 squared. So just write down or substitute the numbers. This is m1 and this is m2. Just write here, okay? So this is half m1, which is 7 times the first velocity. We figure it out, it was 5.7 squared plus the second one, which is half, its mass was 2. This is for the pen, okay? This is for the pen, which is 2, times the velocity, which was 0 at the beginning. So at the end, you can just use the calculator to figure it out. So at the end, the velocity, the kinetic energy equal 113.7 joule, 113 joules. So this is the kinetic energy actually before the collision. Okay, as you can see here, so this is the kinetic energy before the collision. So what you need now is just figure out what is the kinetic energy after the collision. So you can use the same way exactly. So the kinetic energy after the collision equal half m1 v1 dash squared plus half m2 v2 dash squared. Again, this dash just to differentiate between initial and final. So initial, we just say v1, final velocity, we just say it's v1 dash. So just substitute the numbers. Now just substitute the numbers. So the numbers, this is half times m1, which is 7, times v1, which is 4 squared, okay, plus half m2, which was 2, times v2, which was 6 squared. Use the calculator to figure it out. So use the calculator to figure it out. So the final answer will be 92, as you can see here, joule. So if I ask about what is the change in the kinetic energy, so in this case I need to just find the kinetic energy for final minus the kinetic energy for initial. So this is the final, actually this is the final kinetic energy. So we know that the final kinetic energy is 92 minus initial kinetic energy, which is 113.7. Okay, so the right answer will be, okay, minus 21.3 joule. So in this process, actually the object or the system lose about 21.3 joule, okay, during this collision. Of course, this loss of the energy may be in the form of sound, maybe in the form of heat, maybe in the form of deformation of the shape of the objects, but still there is a change in kinetic energy, which means, okay, and a proof that this is an inelastic collision. Okay, guys, so I hope you just enjoy your session today, and goodbye.